We are studying the coordination compounds and we are studying the isomerism. Today we will study the coordination isomerism. Coordinate isomerism or coordination isomerism. Coordination isomerism. Now, this type of isomerism, that means coordinate isomerism or coordination isomerism, occurs in those compounds which have both cationic compounds which have cationic and anionic complex. That means in these compounds cationic part is also complex and anionic part is also complex. That means both cationic part and anionic part are complexes, and isomers differ. Isomers differ in the distribution of ligands. In the distribution of ligands in cationic entity and anionic entity. So this type of isomerism, students, that means in such complex cationic part is complex and anionic part is complex, and isomers differ in the distribution of ligands in the cationic and anionic entity. For example, that means there occurs interchange of ligands. There occurs interchange of ligands in the cationic and anionic इन cationic and anionic part यहाँ पर interchange of ligands होता है. For example, I will write it is CONH3, for example this one, whole 6. This is cationic part, it is complex, and there is in this compound it is CrCN whole 6. Let us name this compound. It is hexaamine cobalt third, and this compound here, this is hexacyanochromate third. Now here there occurs interchange of ligands within the different metal. This is here cobalt is central metal, here this chromium is central metal in the anionic part. Now there occurs interchange of ligands between cationic and anionic part of different metal ions. For example, I will write here another. इसका आइसोमर मैं यहाँ लिखूंगा. Now this इसका आइसोमर it is CrNH3 whole 6 COCN whole 6. Now this compound is tetraamine chromium third, and this is the cationic part, and anionic part is it is hexaamine. Here it is hexacyanocobaltate third. So these two are coordinate isomers. If I will write another example, for example, it is PTNH3 whole 4 CuCl4. So this is tetraamine platinum second. This is the cationic part, and anionic part is tetrachlorohydrocuprate second. Now I will write its isomer here. I will write it is CuNH3 whole 4 and PtCl4. It is tetraamine copper second and tetrachlorohydroplatinate second. So these are the coordinate isomerism. Now in coordination isomerism, they have cationic part is also complex and anionic part is also complex, and the isomers differ in the distribution of ligands. Here in this CoBA, in first cationic complex, amine part is coordinated, and in anionic part complex, cyano group is coordinated. But in its isomer, amine is amine group is coordinated to the chromium cationic complex, and in anionic complex, cyano group is coordinated to the cobalt. Similarly, his in tetraamine platinum amine group is coordinated to platinum, and in anionic complex, chloride group is coordinated to the copper. But in second its isomer, amine is coordinated to the copper and chloride is coordinated to the platinum. So these are coordinate isomer. Coordinate isomers or coordination isomerism इसको कहते हैं. Now this type of isomerism, अगर this type, I will tell you, this type of isomerism occurs in compounds, is shown by compounds. उन कंपाउंडों में ये होता है जहां पर मेटल आयन सेम होते हैं. मेटल आयन्स आर सेम, वहां पर भी दिस कोऑर्डिनेट आइसोमेरिज्म होता है. फॉर एग्जांपल, आई विल राइट इट इज CrNH3 whole 6. It is cationic part and anionic part CrCN whole 6. Now this is one isomer. It is hexaamine chromium third, and it is hexacyano, anionic part is hexacyano chromate third. Both contain chromium as central metal atom. Now I will make its isomer here. It is CrCN whole twice, NH3 whole 4. This is cationic part, and anionic part becomes CrCN whole 4, NH3 whole twice. Now here I have shown you here that there are in cationic there are twice this NH cyano group and amine group, and there are tetracyano group and twice amine group. So this becomes, there occurs interchange of ligands, but the central metal atom is same. So this type of isomerism is known as coordinate or coordination isomerism. Now second type of isomerism which the coordination compounds show, that is called linkage isomerism. That means this type of isomerism occurs in those compounds, in those complexes where there are ambidentate ligands. एम्बिडेंटेड लिगेंड्स उन कंपाउंडों में होता है वहाँ जहाँ पर एम्बिडेंटेड लिगेंड्स हैं. This is shown by, that means these isomers have same molecular formula but differ in point of attachment. For example, students, लिंकेज आइसोमर्स मतलब क्या है, यानी जो आपका आइसोमर्स हैं इस टाइप के आइसोमर्स में वही होता है जहाँ पर एम्बिडेंटेड लिगेंड्स होंगे. दैट मीन्स एम्बिडेंटेड लिगेंड, फॉर एग्जांपल आई राइट NO2. It has both oxygen can donate and nitrogen can donate electron. When nitrogen donates, it is nitrito N. So point of attachment is nitrogen, and if it is NO, it is nitrito O. So point of attachment is O. So the compounds have same molecular formula, but they differ in the point of attachment is due to the point of are different in the point of attachment. They are different compounds, but they are isomers. For example, I'll write it here: CO NH3 whole pentaamine NO2. I'll write it. This is the compound. This is pentaamine nitrito N cobalt third chloride. So if I write here इसका आइसोमर मैं लिखूं, it is CO NH3 whole 5 ONO Cl2. Now here another ligand is, यहाँ पर आपका ligand जो था NO2 nitrito था, तो attachment was through nitrogen, and here it is also, but attachment is through oxygen. So it is pentaamine nitrito O cobalt third chloride. So these two are isomers. So this, in case of, students, linkage isomerism is shown by those compounds in which there is embedded ligands. That means the embedded ligand has two donor atoms, but at one time it donates only one atom, donates electron. So for example, nitrito, it has, and nitrito, it has both nitrogen and oxygen can donate electron. If nitrogen donates, it is nitrito O. If oxygen donates, it's nitrito. If nitrito N, if oxygen donates, it's nitrito O. Similarly, I will show it here. If it is SCN, it is thiocyano. Both sulfur and nitrogen can donate. So if it's NSC, it is isothiocyanate. So this is the embedded ligand. For example, there is another ligand CN. It is cyano, if because carbon donates. If nitrogen, it is NC, it is isocyano. So these isomers differ in the point of attachment. So when the isomers differ in the point of attachment with the ligand, these isomers are called linkage isomerism. These were the types of. So you have read types of isomers. For example, you have read first ionization isomerism, and second you have read hydrate isomerism, and third you have read coordinate isomerism, and fourth you have read the linkage isomerism. These were the four types of structural isomerism in coordination compounds. Thank you.